So for the first part, we calculate the Carnot efficiency by using equation 15.5, and then we compare it to the 15% actual efficiency. So the Carnot efficiency according to this equation is equal to 1 minus the low temperature over the high temperature, and we need to plug these two temperatures in Kelvin. So we have 85 plus 273 Kelvin here, and then this much in the denominator, and this is equal to 0.534. So this, multiplying it by 100, we get the percentage, and that is equal to 53.4%. And the actual efficiency is given to be 15% or 0.15. So if we compare these two, the engine's relative efficiency will be E actual over E Carnot, and that is found to be 0.281 or 28%. And then for the second part, we take the stated 135 HP as the useful power obtained from the engine. So power is equal to W over T, and that's equal to 135 HP times, so we have 746 watt per HP. Just hold on, let me write this properly. So we have 746 watt per HP, so we multiply that so as to get our power in units of watts, and that is equal to 1.01 times 10 to the power 5 volts. So that's the useful power. Now let's use the efficiency to calculate the exhaust heat. So efficiency is equal to work over QH, and that is equal to work over, so the QH is the heat input, and that is equal to heat output plus watt turn, and this means that QL will be equal to W times 1 over E minus 1, and work is, so QL is equal to, so work is basically power times time, and we already calculate the power in the first part, not in the first part, over here in the second part, times 1 over E minus 1. Now it's time to substitute the value. So we have power, and then the time is 1 hour, and since the power is in watts, and you know that watts is actually joules per second, so we should have the time in units of second for our units to be consistent. So we have 3600 seconds in 1 hour, so we multiply that factor, and then we need to multiply E, which is 1 over E, so 1 over E point, okay, let me just write 1 over E minus 1 here and move on to the next page to write the full expression along with all the calculations. So that's the power, then time is 1 hour, and we are converting the time into seconds here. So basically here we get the time in seconds. So there's the conversion going on. And then we have 1 over E, that is 0.5 minus 1. and this gives the exhaust heat or the heat output, and that is calculated to be 2.054 times 10 to the power 9 joules, or roughly equal to 2.1 times 10 to the power 9 joules. And if you want to convert this into calories, this will be equal to 4.9 times 10 to the power 5 kilocalories. And here I'm using the usual conversion as 1 calorie to be equal to 4.186 joules, and 1 kilocalorie is 1000 calories.